C upon A minus sine hyperbolic B upon A. This A into this value, which is A here, this one. A into sine hyperbolic C upon A minus sine hyperbolic B upon A. This is S. Therefore, A comes out to be A into small s. A into S. Therefore, area is S times A. Okay. This is area A into S. Therefore, area is length of the arc times A. A is constant here. So this is proved. Question 6 was in the catenary test. Prove that the area between the curve x-axis and the ordinates of 2 points on the curve varies as the length of its intervening arc. So this is the length of the arc. Area varies as the length of the arc. Okay. Hence it is proved. Hence area, because this is A square into S. Sorry, A into S. A square into this. So, but A into this was S, the arc length of the arc here. Let me write here S. Therefore, area varies 8 times the length of the arc. The length of its intervening arc. Why intervening? Because we have taken the same ordinates between B to C. Because of the two ordinates between the same ordinates, and area is also between the two ordinates. So, therefore, the line is intervening. This length of the intervening length or intervening arc is S times this A. So area is given. Hence it is proved. So this we have proved here. Hence proved. Intervening arc, length of its intervening arc varies as 8 times the length of its intervening arc. Hence it is proved. Hence it is proved. This is question number 6 we have done. Now let me take question number 7. What is question number 7 say? Let me check it. Okay, so question number 7 says, find the length of an arc of the parabola measured from the vertex. Okay, so if I take length of the parabola, any parabola measured from its vertex to any point, if I take y coordinates, it is 0 to y coordinate, or if it is 0 to x, so x coordinate can be there. The formula we have taken. What is the formula? Let me take that. Okay, so question number 7 here. So area length of the length of the arc of a parabola okay, from its vertex to a point. Let me take pxy on it. Okay, so we have taken vertex is 0, 0. So parabola, if I take, let the parabola is y square equal to 4ax. Y square equal to 4ax. From 0 to y, here y coordinate we have to take dx dy with respect to y. If I differentiate it, the solution here. Okay, so this we have to differentiate, with respect to y. Find differentiating it with respect to x here, with respect to y. So differentiating first with respect to y, because it is symmetric about x-axis, because y is even forward. With respect to y, so we get 2y is equal to 4a into dx dy, or dx dy is equal to y upon 2a, which we have done. Therefore, length of the 1 plus, let me take 1 plus dx upon dy whole square equal to again 1 plus y square upon 4a square is equal to 4a square plus y square upon 4a square. Therefore, length of the arc from 0 to y, from y equal to 0 to y equal to y coordinate we are taking. It will be s equal to 0 to y. It is now 1.2a square root y square plus 4a square into dx, or it is dy here. So we are differentiating with respect to, integrating with respect to y. Integration with respect to y we are calculating. Y here is this. Therefore, integration is 1.2a. Alright. And this is within limit 1.2 y into square root y square plus 4a square plus 1.2 4a square into log of y plus under the square root y square plus 4a square. Okay, this is 0 to y limits here. If I put 0 to y limits, let me substitute that. Therefore, the area will be finally, therefore s equal to 1.2. If I put the upper limit y, it will be y only, the same formula. It is 1.2a. So 1.2a. Okay, so let me solve it. It is nothing but 1.2 into y, because upper limit is y here. It is y square plus 4a square plus 2a square into log of y plus under root y square plus 4a square minus sign, this is 2a square. Y is 0, lower limit is 0. So in place of y we have to substitute 0. So it will be log 0 plus y square 0. So it is 4a square, that means log of 2a. Log of 2a only. Now, if I take 2 common from this point, that can also be done. So this is 1.2a. This is y upon 2 under the square root, which is y square plus 4a square. If I take plus 2a square common, it will be log of y plus under root y square plus 4a square upon 2a. Upon 2a. This is the value. Okay, and if I take, this is the curly bracket, I'm sorry, and this is the curly bracket here, then this is the answer. Final answer is this. This is in terms of the y. Okay, by coordinate only, because the upper limit is not given. It says take any point on the curve. So we have taken pxy up to y, 0 to y we have taken. Okay, from vertex, it says in the, sorry, this 7th question, find the length of the arc of the parabola measured from the vertex. So from vertex to any point are taken only y square equal to 4ax. We have taken the parabola, equation of parabola. We could take x square equal to 4ay. That could also be done. So in that situation, it will be x then x plus x square plus 4a square. It is x here, x upon 2a. So that is also possible point. Or if parabola is, let me write here, if the parabola is x is equal to 4ay, then it will be, then s is equal to 1.2a, in bracket is x upon 2, under the square root it is x square plus 4a square plus 2a square, we have taken common, into log of x plus under the square root x square plus 4a square upon 2a. This is answer in terms of, if this is the parabola, then this is the answer. If parabola is above y square equal to 4ax, then this is the answer. So this is the question. 7 we have done. Now if I take the question number 8, let me check it. What does question number 8 say? Let me now find it out. So here question number 8. Show that the length of the curve y equal to this between points where x equal 0 to x equal to pi by 3 is this. We have to prove here. Question number 8, let me take to show length of the arc of the curve. This is arc here. Arc of the curve. What is the curve here? Curve is given y is equal to log of secant x. Log of secant x between x equal to 0, between the ordinates x equal 0 to pi by 3, 1.3 pi or pi by 3 is this. Is length of the arc is, or s equal to, with that is log of 2 plus root 3. The log of 2 plus root 3. This is the length of the arc. We have to prove this. Show this. Okay, so here solution. Let me check it. So length of the arc here, y is here, y is this. So this is log of secant x. Differentiating it with respect to x here, so y is given, but ordinates are for x. So with respect to x, differentiating it with respect to x. Differentiating this is the first equation. Differentiating it, or the equation this first with respect to x. So we get dy dx is equal to, this is log of secant x, so 1 upon secant x into differentiation of log of secant x is 1 upon secant x, but secant x is again differentiated. It is secant x into tan x by function of a function method. 1 secant x cancel out, so this is nothing but tan x. Okay, so this is tan x here. Dx is, and limits are this to this. So let me write. Therefore, 1 plus dy dx whole square is equal to 1 plus the tan square x equal to secant square x. This value is therefore square root of 1 plus dy dx, because dy dx is tan x. So this is 1 plus tan square x. That means secant square x is the formula from trigonometry below. Secant square x is 1 plus tan square x. This is square root of this, therefore is square root of secant square x. This is equal to secant x. Alright, therefore length of the arc is given by s equal to is given as s equal to sine of integration. This is x equal to 0 to pi by 3. Okay, and this is, let me write the first formula, 1 plus dy dx whole square into dx here. So this is x equal to 0 to pi by 3, and this is secant x. We have taken only secant x into dx. What is the integration of this? Let me write here. The integration of secant x is log of secant x plus tan x. So s equal to log of secant x plus tan x. Now limits we have to substitute here. It is 0 to pi by 3. Okay, 0 to pi by 3. Now let me solve it further. The further solution of this equation will be, it is, if I put upper limit, it is log of secant pi by 3 plus tan pi by 3 minus log of secant 0 plus tan of 0 with minus sign. What is this value? Log of secant pi by 3 is 2. So log cos of pi by 3 is 1.2, so it is 2 only. It is 2 plus tan pi by 3 is, this is 60 degree, root 3 only. Because tan 30 degree is 1.3, and tan 60 degree is root 3 only. Why root 3? Because tan 60 means sin 60 degree, pi by 3 means 60 degree upon cos 60 degree. With this trigonometry we know about, cos sin 60 degree is root 3 by 2, and this is 1.2, 2 cancel out, only root 3. So tan 60 degree is root 3 minus log of, this log 0 is 1, because cos 0 is 1, 1.1 is 1, tan 0 is 0, plus 0, if the log 1 is 0. It is only log of 2 plus root 3, log of 2 plus root 3, that is the value. Okay, log of 2 plus root 3, this is the answer only, because log 1 is 0, as since log 1 is equal to 0, this is 0 here, only this value is the answer. This is the answer, hence proved. Hence we have shown this. So log of 2 plus root 3 is the final answer of this length of the arc. Okay. Question number 8. Now 8th question we have completed. Let me talk about 9th. What does question number 9 say? Let me now check it. Question number 9 here. It says find the length of the arc of the curve a by square equal to x cube from the vertex 0, 0 to AA. Okay, let us find out this. So curve is here, curve is, and the length of the arc of the curve a y square equal to x cube. It is from the vertex 0, 0 to the point this, from 0, 0 to what is the point AA. Okay, so limits 0 to A we have to put. So here we have to differentiate it with respect to, let me take x here, dy dx if I calculate. So x cube equal to this value. If I differentiate it with respect to y, let me take. So what's the solution? We can find out in any way. It is differentiating it with respect to y. Differentiating it with respect to y. So we get, it will be twice a into y is equal to, this is 3x square first, then dx by dy. You can calculate in any way. We can find out dy dx also with respect to x. We could also do, that is also possible. So in both way answer will be same. 3x square dx dy. Let me just check. So therefore dx dy is equal to, this is 2a by upon 3x square. Okay, so this is 2 by is equal to, or if we find out dy dx, so even then it comes out in terms of y. It is 2a by upon x square. In case of this y, we have to substitute y so that it can be in terms of x only. Okay, if or in terms of y only, so x square, we have to calculate then what is x square in terms of y. Or if I find out in terms of x, then can also be possible. So let me first solve it with respect to x here. That will be simpler. Also, any way we can find out with respect to x, we get, with respect to x, it will be twice a by into d by dx equal to 3x square. Therefore d by dx is equal to 3x square upon 2a by 3x square upon, it is twice a into y. What is y here? So y square equal to, this is x cube by 2 upon a raised power 3 by sorry, only 1.2. It is a upon 1.2 because y square equal to x cube upon a. Therefore, y is equal to x raised to 3 by 2 square root of x cube upon a square root is a 1.2. This is only under root a. That means this is nothing but 2 minus 3 by 2 power. This x will come in the numerator, and upon 2 into under root a square root a, constant value. It is nothing but 3 into x raised power 4 minus 1 is 1.2 half power upon 2 under root a. So in any way we can do like this, not a problem. Okay, so this is d by dx. D by dx we have calculated. Therefore 1 plus d by dx whole square is equal to 1 plus whole square of this is 9 into x only divided by 4 into a is also square root. Okay, so x is also square root, so both square root cancelled out. It is nothing but 4a plus 9x upon 4a. Therefore, square root of this value 1 plus d by dx whole square. Square root of this is square root of 4a plus 9x divided by 2 under root a. This is the value. Now let me find out the length of the arc. Therefore, length of the arc of the curve is given by s equal to sine of integration 0 to a limits. Here x limits are calculated. X ordinates we have to take. So 0 to a, same 0 to a in case of y also 0 to a. It is this value under the square root 4a plus 9x divided by okay, this is square root 2 under root a into dx. We have to integrate this value. So the integration of this simple question. Okay, so this is the point here, s equal to this value. So this is, let me take 1.2 root a outside, 0 to a limits. This is under the square root 4a plus 9x. Now what the integration of this? So this is only the square root value. Okay, so into dx here. You have to integrate this question, and then the final putting the limits. What the value of this question? This is power half. So we can write this as 1.2 root a. 0 to a here. This is 4a plus 9a power half into dx. Half power. Okay, so if I put 4a plus 9x equal to that, we take t, then of t square, putting 4a plus 9x equal to t square, right? T square, so that it can be converted. It will be so converting the limits and differentiation, it will be 9 dx twice t into dt. Okay, this is the value of this. It is therefore dx equal to 2 upon 9 into t into dt. This is the value of t here. Now limits, putting the limits here. What are the limits here? When x equal to, here x equal to a, it will be 13a, then x equal to a, it will be 13a t square equal to, t equal to then under root of 13. T square equal to, let me take x equal to a, t equal to 13a, because 4a plus 9a, that means 13a, or t equal to under root 13a, square root 13a. At 0, it is 4a, so t equal to 2 under root a. And at x equal to 0, t square equal to 4a, and t equal to 2 under root a. Okay, so limits are 1.2 under root a. Let me write here. Limits are now. First is 2 root a to under root 13a. Okay, so under root 13 into under root a, no problem. It is now t square, that means t only, into t into dt, 2 upon 9. It is t into dt into 2 upon 9 here. I have taken outside. Integrating it with respect to t now, this is 1 upon, okay, it is 2 to cancel out, 9 under root a. 1.9 under root a. Okay, it is now t square means tq upon 3 integration. Putting the limits here, 2 root a to under root 13a. Under root 13a. Okay, so finally answer is, final answer will be, let me write here, 1 upon 9 under root a. tq, if I put upper limit root 13, that means this is 13a whole power 3 by 2. 3 by 2. And 3, let me take outside. It will come out as 1.3 into 1.3. Or it is 27. So the value will be 1.27. 27 under root a. Why? Because 9 into 3 is 3. Then put the limits. So this is 13a whole power 3 by 2 minus this is 2a raised power half whole power 3 by 2 whole power 3 by 2. Okay, this a is also half power. This is 3a by 2, 3 by 2 power of both. Okay, and this was also 3 by 2 of power half. No, this power, I'm sorry, this 2 raised power 3, but a, this is like this, I'm sorry, 2 only, 2 root a whole power 3. This we have to solve. Okay, so finally here 13a bars square root, this is 3 by 2 power, but this is 2 under root a whole power 3. Now that you further solve it, 1.27 under root a, then bracket, now it is 13, okay, q root of, this is, sorry, first q times 13 will come out, and 13, it is 13 root 13, it is a raised power 3 by 2, okay, and minus sign a raised power 3 by 2 will come out, it is 2 root 2, sorry, it is 8, I'm sorry, it is 8 here, sorry, it is 8 into a raised power 3 by 2. So if I take a raised power 3 by 2 out, it will be a raised power 3 by 2 minus 1.2 divided by 27, in bracket it is 13 root 13 minus 8. Okay, so this is a, because 3 by 2 minus half means 1 and a half, 1 cancel out, so a upon 27. Then it is 13 root 13 minus 8. This is the value. Question number 9 is giving us this answer. This is the answer here. Question number 9 is giving us this value. This is a upon 27. Within the bracket it is 13 under root 13 minus 8. Okay, so this is the answer. Question number 9. Now 10. Question number 10. Prove that the length of the loop of the curve 3a y square is equal to x into x minus a square is 4a root 3. Okay, so that we have to find out length of the, prove the length of the loop of the curve is. first that curve is to be okay. So that curve is symmetric to the x-axis because y square is in even power. Y is in even power. Okay, so this length we have to find out that this length is this much. Let me take that length. So limits we have to first find out the loop, the length of the loop, twice of that loop. Okay, so what's the loop here? Let me check question number 10. So question number 10 here is question number 10. It says that 3ay square is equal to 3ay square equal to x into x minus a whole square. Okay, the length of its loop. Okay, so length of its loop will be what? So let me just find out that what is the length of the loop between the points of this curve. So this curve is, sorry, length of the loop is length of its loop is, with that we have to prove that it is 4a root 3. This we have to prove. To prove this, to prove the length of the loop is this much. Okay, so we have to prove this question. What is the ellipse here? So here solution, let me, sorry, this loop here. Here the loop is symmetric about, or the curve is symmetric about x-axis. Okay, if I put y square equal to 0 or y equal to 0, then this is x equal to 0 and x equal to a. If so, putting y equal to 0, so we get x equal to 0 and x equal to a. Why? In that situation, x minus x whole square equal to 0. Y square is 0, then it will be x equal to 0 and x equal to a. It means the curve is meeting the x-axis at a0 and 0, 0. Okay, so the loop meets the x-axis at 0, 0 and a0.